Dear students, in this video you are going to learn about criteria for similarity of triangles. What do you mean by criteria for similarity of triangles? It means the minimum corresponding parts required to prove the two triangles are similar. What is the minimum requirement to prove the two triangles are similar? That you are going to learn in this video. Recall that you have learned about criteria for congruency of triangles in your 9th standard. Now recall the definition of similarity of triangles. True triangles are said to be similar if their corresponding angles are equal and their corresponding sides are in the same ratio, or their corresponding sides are in proportion. So if the corresponding angles are equal and the corresponding sides are in the same ratio in two triangles, then the triangles are said to be similar. This is the definition of similarity of triangles. Now take an example. Take two triangles, triangle ABC and triangle DEF. In triangle ABC and triangle DEF, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. So two triangles ABC and triangle DEF, if angle A is equal to D, angle B is equal to E and angle C is equal to F, and AB by DE is equal to BC by EF is equal to AC by DF, then the two triangles are similar. If all the corresponding angles are equal and the corresponding sides are in proportion, then the two triangles are similar. Symbolically, we write the similarity of these two triangles as triangle ABC similar to triangle DEF. Observe the symbol for similarity of triangles and read it as triangle ABC is similar to triangle DEF. The symbol stands for is similar to. Observe the symbol of similarity. The symbol stands for is similar to. Observe the symbol of congruency. The symbol used for is congruent to. Differentiate between the symbol of congruency and symbol of similarity. Now the question arises. To check the similarity of two triangles, should we always look for all the corresponding parts? Means, should we always check for all the corresponding angles and the ratio of all the corresponding sides? Is it necessary to check all the 6 corresponding parts? Let us examine now. Recall that you have learnt about SSS, SAS, ASA and RHS criteria for congruency of triangles. Now let us make an attempt to arrive at certain criteria for similarity of two triangles involving less number of pairs of corresponding parts of two triangles. Now let us perform the activity. Now first activity is draw two line segments BC and EF of two different lengths, say 3 cm and 6 cm. It can be of any measurement. No need of drawing 3 and 6 only. You can draw two line segments of any measurement. At the points B and C respectively, construct angles of some measures, say 60 degree and 40 degree. You can construct angle of other measurements also. Now at the points E and F, you have to construct angles of measure which you constructed at B and C. Angle at B and C should equal to angle at E and F. Now you have to construct two triangles, triangle ABC and triangle DEF. After constructing two triangles, you have to measure the remaining angle and the sides. You have to measure the sides and you have to measure the remaining angle. Now I have constructed two triangles with angles 60 degree and 40 degree. Here I have constructed two triangles with their two corresponding angles are equal. I have constructed angle B is equal to angle E, angle A is equal to angle D, and here angle AB is equal to 6 cm, D is equal to 3 cm. Now let one more vertex as C. Now one angle is 60 degree, another angle is 40 degree. What is the third angle of triangle? That is equal to 80 degree, because sum of angles of triangle is 180 degree. So no need of measuring third angle, it will be 80 degree because of angle sum property. Now measure the length of the sides. After that, take the ratio. Now in the triangle I have constructed the ratio of sides, that is D by AB is equal to 3 by 6. Then EF by BC is equal to 0.5. Then AC by DF is also equal to 0.5. Means corresponding sides are in the same ratio. We have constructed two triangles with their two corresponding angles are equal. Then their corresponding sides are always in proportion. We have constructed two triangles with their two corresponding angles equal. Third angle will automatically be equal because of angle sum property. In this case, if we measure the sides and if we take the ratios, then the ratio of their corresponding sides is equal. You can change the measurement of angles. See here. It is not necessary to construct 60 and 40. You can take 70 and 50 or anything. You have to take two corresponding angles of two triangles should be equal. And you can change the length of the base also. See here, AB is 5.5, D is 3. Here we have to construct two triangles with their corresponding angles equal. Then always their corresponding sides are in the same ratio. This is called AAA, criteria for similarity of triangles, or you can say AA criteria, because if two angles are equal, then the third angle will always be equal because of angle sum property. So this is called AA criteria for similarity of triangles. Let us state AA criteria for similarity of triangles. See here, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or their corresponding sides are in proportion and hence the two triangles are similar. This criterion is referred to as the AAA criterion of similarity of two triangles. Angle criterion of similarity of two triangles. If in two triangles corresponding angles are equal, then the two triangles are similar. This is called AAA criterion of similarity of two triangles. Now see here, if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of a triangle, their third angle will also be equal. If two angles of a triangle are equal to two angles of another triangle, then by angle sum property of triangle, their third angle will also be equal. Therefore, AAA similarity criterion can also be stated as follows. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. To check whether two triangles are similar or not, it is enough if you check two angles of one triangle equal to two angles of another triangle or not. If two angles of one triangle are equal to two angles of another triangle, then the two triangles are similar. This may be referred as the AA similarity criterion for two triangles. So instead of saying AAA similarity criterion, we can say AA similarity criterion. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. This is called AA similarity criterion. Now let us arrive for one more similarity criterion. For this you have to draw two triangles ABC and DEF such that AB is equal to 3 cm, BC 6, CA 8 cm, DE 4.5, EF 9 cm and FD 12 cm. See here, we have to construct these two triangles ABC and DEF. Here, look at the ratio of the sides. Now, here AB is correspond to DE. Now, take the ratio of AB and DE, that is AB by DE is equal to 3 by 4.5, that is 2 by 3. You can take the ratio of DE by AB also. Now take the ratio of BC by EF, that is 6 by 9. is equal to 2 by 3. CA by FD is equal to 8 by 12 is equal to 2 by 3. Now here ratio of the corresponding sides are equal. You can take DE by AB, BF by BC and DF by AC also. Then it becomes 3 by 2, that is 1.5. Here we have constructed two triangles such that their corresponding sides are in the same ratio. You have to construct two triangles such that their corresponding sides are in the same ratio. Now let us verify this, whether their corresponding angles are equal or not. Now see here, I have constructed triangle ABC and triangle DEF such that their corresponding sides are in proportion. See there, FE by CB, EF by BC is equal to 1.5, DE by AB is equal to 1.5, then AC by DF is equal to 1.5. You have to measure the length of sides of your triangle and you have to take the ratio. Here the ratio of the corresponding sides is equal. Now you have to measure the angles. Here corresponding sides are in the same ratio. Now you have to check whether the corresponding angles are equal or not. If the corresponding angles are equal, then the two triangles are similar. Now let us check it. Now measure angle C, that is 25.9 here, angle A 93.1 here, and angle B is 61 degree. Now angle D is 93.1, angle E 61, angle F 25.9. Yes, all the corresponding angles are equal. Here we have constructed two triangles with their corresponding sides are in the same ratio. Then we have got their corresponding angles are equal. So the two triangles are similar. This is called SSS, Similarity Criteria. If we construct two triangles such that their corresponding sides are in the same ratio, then their corresponding angles will always be equal. This is referred as SSS, Similarity Criteria. Remember, you have to construct two triangles with their corresponding sides are in the same ratio. Now let us state SSS similarity criteria. If in two triangles, sides of one triangle are proportional to the sides of another triangle, then their corresponding angles are equal and hence the two triangles are similar. This criterion is referred as the SSS similarity criterion for two triangles. Remember this, if sides of one triangle are proportional to the sides of another triangle, then the two triangles are similar. This is called SSS similarity criterion or side similarity criterion. So If you know the measurement of sides in two triangles, you have to look for the ratio of the corresponding sides. If they are equal, then the two triangles are similar. Now third activity, for another criteria, draw two triangles ABC and DEF such that AB 2 cm, angle A 50, AC 4, DE 3 cm, angle D 50 degree, DF is equal to 6 cm. Now see here, AB by DE is equal to 2 by 3. Angle A is equal to angle D, and AC by DF is equal to 2 by 3. Here we have to construct two triangles such that one angle of one triangle is equal to one angle of another triangle, and included sides of the angle, including sides of the angle, should be in the same ratio. We have to construct two triangles with one angle of one triangle equal to one angle of another triangle, and sides including the angle should be in the same ratio. Now let us verify this. Here I have constructed two triangles with angle B is equal to angle E. Angle B of one triangle is equal to angle E of another triangle, and sides including the angle B means AB and BC. Sides including angle E is EF and ED. Now here AB by DE, that is 2 by 3, BC by EF is equal to 2 by 3, are in the same ratio. Remember, we have to construct two triangles with one angle equal and the sides including that angle should be in the same ratio. Then we have to check the remaining angles and the remaining sides. Now here the length of remaining sides, that is AC and DF. After that we have to look for their ratio. Now I am taking DF by AC, that is equal to 1.5, or you can take AF by DC also, then you will get 2 by 3. 2 by 3 is equal to 0.6 something approximate. So if we construct two triangles with one angle equal and their including sides of the angle are in the same ratio, then the remaining corresponding angles are equal, so the triangles are similar. Now angle C is equal to angle F here. Now see the measurement of angle C, that is 100.56. Now angle F also 100.56. Angle A is 29.44. Here angle D is 29.44. So all the corresponding angles are equal and all the corresponding sides are in proportion. So the two triangles are similar. This is referred as SAS similarity criteria, because we have constructed two triangles with one angle of one triangle equal to one angle of another triangle and including sides of the angle are in proportion. Hence, the two triangles are similar. This is the third criteria for similarity of two triangles. Now let us state SAS similarity criteria for two triangles. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, then the two triangles are similar. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, then the two triangles are similar. This is referred as SAS similarity criterion. So if two sides and one angle is given, then we have to check whether two angles are equal and whether the sides are in the same ratio. Then the two triangles are said to be similar. So we have learnt three criterion to prove the two triangles are similar: AA criteria, SSS criteria and SAS criteria.